Alright, so this is gonna be a quick tutorial in how to install and use Octave. For those of you that are not familiar with Octave, Octave is a computational software that is extremely similar to MATLAB and is the computational package that we're gonna be using for the remaining of the spring semester. So the first thing that I'm gonna do is I'm gonna open my web browser. In this case, I'm using Firefox, but you can use Chrome, you can use Safari, whatever you want to use. And then I'm gonna type in Google, I'm gonna type GNU Octave and tap enter. I'm gonna go into the first link that shows, and this is gonna bring me to the front page of the GNU Octave website. When I hit download, it will pretty much scroll down the window to the install section. And for sake of simplicity, I'm gonna assume that we're all using Windows. So I'm gonna tap on the Windows tab, and I will look into the Windows 64-bit, the recommended section. I want you to download the .exe file, this first one right here. Unless you know how to deal with compressed files, I will stay away from these two guys. So download the .exe. It will take a little while to download, and then in this case I already downloaded. When you click on it, you just have to go through the installation process. It's a matter of hitting yes, yes, I agree, yes, go for it, and then it's gonna take about 10 minutes to install. So in this case, I already installed it. It's not a difficult installation process. If you have any issues, please just send us an email, send us a message through web courses. Once you have it installed, you see it right here. I have the GUI, I have the graphic user interface. That's the one that I'm going to be using. So I'm going to double click on it and wait for it to open. And there you go. This is GNU Octave. It looks extremely old, extremely clunky, but all the same, it's the same idea as an old MATLAB, for example. So I'm gonna go ahead and show you. Some of the commands still work. So right now I'm in the command window. This is the command window. This one is my working folder. So here you see the file browser. I can go to where my files are. This is the workspace. As I mentioned when we were going over the tutorial for MATLAB, workspace is the place where your variables, where you can see the values of your variables when they're created, answers and anything like that. Command history, if you're using the command window, it will pretty much just shows you things that you have typed before. And different than MATLAB, and you don't have as much thing on the top. You have your command window down here. Documentation, you don't really need it. And variable editor, I will stay away from that too. But here's your editor. So the editor is where you will be creating your scripts, where you're going to be creating your file, and you're going to see all the different files here at the top. So it's a little, it takes a little while to get used to it, to the navigation and where things are. But in the next video, once I'm actually going over the project, I'll make sure to talk more about this. So let me just show you a quick kind of like how you can use this. And as I mentioned before, it's used in the same manner. I can use CLC to clear my command window. If I create a variable x equals to 1, there you go. It has it on the workspace. There is a variable x, it's class double, the dimensions and the value, and I can always hit clear to clear my workspace. I can also use close all in case that I have any graphs or any tables that I want to close. But to keep it simple, let's say I want to create a variable x that goes from 0, counting by 0.1, all the way to 10. Suppress that output at the end, and then I'm going to create another variable y that is the sign of x. Then if I want to plot this, I will do it in the same manner. Plot x comma y, close it, and then there should be my plot. So it's the same idea. We can use the same, you can say grid on axis equal as we did in the lab. And you can see that the grid on axis equals tries to make the axis the same size, so that's why it seems shortened. And then it puts the grids on the graph. So many of the commands, many of the syntax that we use in MATLAB are gonna work in this case. One of the main concerns that I have is, for example, if I say fprintf hello and it prints hello, Octave, it's different. Let me just clear it and write it this way, CLC. So if I do hello, there's my hello. In Octave, if you use, instead of using the double quotes, you use single quotes, it still works. This is the type of freedom that I talked about before and that you have to be extremely aware of. The Octave allows you for write things whatever way you want. It doesn't force you to write them in a specific way. So if you're using MATLAB or if you're using Octave and you're using the same file for both of them, it's always a good idea to go back and check that it actually in fact worked rather than just assume that the code worked, because again, they're very compatible. That's the objective of Octave, is to be as compatible to MATLAB as possible. However, little things like this will give you errors, and these are the errors that you want to, syntax errors, you want to avoid during your quiz or during your project, because again, they will slow you down and it's just an extra headache, because programming is 10% writing the code, 90% what did I do wrong, just the debugging process. But that's it, that's everything. So play with it and I hope you like it.